You spent $150 on compost, liquid fertilizer, and transplant solution this spring. Half your seedlings are failing anyway. The roots are shallow. The leaves are pale. You're doing everything correctly by the book, and the plants are still dying. Japanese farmers in rural prefectures watch this happen to Western growers and recognize the real problem immediately. It isn't nutrients. It isn't watering. It's the soil itself. Dead, sterile, empty. They fix it with a liquid they collect from the forest floor. It costs $0. Plants recover in days. Yields come back. Here's the system, and here's how it works. Here's what you do when a plant fails. You check the soil moisture first. Maybe you've been underwatering. You water more. Nothing changes. You check for pests. You spray. Still nothing. You buy a bottle of liquid fertilizer from the garden center. You apply it at the recommended rate. The leaves stay yellow. The stems stay soft. You buy a root stimulator. You apply that too. You spend another afternoon reading forums, adjusting pH, adding calcium, testing the runoff. The plant dies anyway. You pull it out and plant a replacement. The replacement starts failing 2 weeks later. This is the loop. Most growers in it don't recognize it as a loop. They see each problem as a separate event. Yellowing leaves in June, wilting in July, fungal issues in August. Each one gets its own product, its own diagnosis, its own set of instructions from the back of a bottle. But the problems aren't separate. They're symptoms of the same underlying condition. The soil has nothing alive in it. Think about what you're spending to stay in this loop. A bottle of liquid fertilizer runs $18 to $35. A root stimulator costs another $22. A fungicide for early blight or powdery mildew adds $15 to $30 per application. Calcium supplements, magnesium sprays, pH adjusters, beneficial bacteria capsules you sprinkle in at transplant time. Add it up across a season. Most home gardeners with 2 or 3 raised beds spend $200 to $400 per year on soil amendments and plant health products. And the plants keep failing at the same rate. Here's what most people miss. You're not buying solutions. You're buying suppression. The fertilizer forces a nutrient response in a plant that can't properly uptake nutrients because the root zone has no microbial activity to unlock them. The root stimulator encourages growth in soil that has no biological structure to support it. The fungicide kills the pathogen on the leaf surface, but does nothing about the stressed, immune-compromised plant that couldn't resist infection in the first place. You are spending money to temporarily manage symptoms in a system that is structurally broken. The structure is the soil, specifically what's living inside it, or what isn't. Healthy soil is not dirt, it is a living system. 1 teaspoon of undisturbed forest soil contains more microorganisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes, microarthropods. They work in networks. Fungal hyphae connect plant roots across meters of soil, transporting phosphorus and water in exchange for carbon. Bacteria fix nitrogen at the root surface, or protozoa consume bacteria and release nitrogen in plant-available form. Beneficial fungi colonize roots and physically exclude pathogens from entering the tissue. This system evolved alongside plants over hundreds of millions of years. Plants are not designed to function without it. Your raised bed doesn't have it. Most raised beds start with a bagged soil mix. Pasteurized compost, perlite, vermiculite, completely sterile. The pasteurization process that makes the compost shelf-stable kills the microbial community that makes soil functional. You fill the bed. You plant. For the first season, the preloaded nutrients carry the plants. They grow. By season 2, the nutrients are depleted. The microbes that would naturally cycle nutrients, suppress disease, and build soil structure were never there to begin with. The plants start failing. You add more product. The cycle repeats. Commercial fertilizers make it worse. Synthetic nitrogen applied at high rates disrupts soil pH and creates conditions hostile to beneficial fungi. Pesticide residue, even residue from products labeled safe for food gardens, reduces microbial diversity in the root zone. Tilling breaks fungal networks. Every intervention you make to fix the visible problem compounds the invisible one. You're not making the soil worse by accident. You're making it worse by following advice designed for a different system. Conventional gardening advice assumes your soil is already biologically neutral. It isn't. It's being actively degraded by the inputs you're using to try to fix it. Here's the reality. The more products you apply, the more dependent the plant becomes on external inputs. You've created a system that cannot function without constant additions. That's not a garden. That's a hydroponic setup with dirt as the medium. And it costs you money every season to maintain that dependency. Japanese and Korean small farmers recognized this pattern centuries ago. Not through modern soil science, through observation. They watched what happened to plants grown in forest soil versus field soil. They watched how plants growing near old-growth trees and deep leaf litter behaved differently from plants in open, tilled ground. They asked why. They looked closely at what was physically present in the thriving soil that wasn't present in the failing soil. The answer was visible under the right conditions. A white, thread-like network coating the underside of old leaves and the surface of rotting wood. Mycelium, living fungal networks, the signature of biologically active soil. They didn't call it that. They called it what they saw, something alive in the old forest that wasn't alive in the field. And they asked the next question. Can we take what's alive in the forest and bring it to the field? Can we give the field what it's missing? The answer was yes. The method was simple. The cost was zero. And it worked well enough to be passed down through generations of farmers who had no budget for inputs and no access to a garden center. They were growing food in poor soil with no margin for failure. The system they built had to work. It did. It still does. For centuries, $0 in inputs, and plants that could survive drought, transplant shock, and cold. The soil was the technology. The microbes were the workforce. Your design creates the problem. Then you buy solutions. The alternative is to stop buying solutions and start redesigning the soil. That starts with understanding what the Japanese farmers found under the old leaves, and what they did with it. The answer costs nothing to collect. In the mountainous regions of Japan and Korea, small farm families grow vegetables in soil that has never seen a bag of fertilizer. They don't buy fungicides. They don't buy root stimulators. They don't buy anything to put into the ground because they don't need to. Their plants survive late frosts and dry summers, and the stress of transplanting in a way that plants in treated beds don't. The difference isn't the seeds. It isn't the variety. It isn't the climate. It's what's living in the soil before the seed goes in. Korean natural farming practitioners and traditional Japanese growers have been cultivating a specific class of soil amendment for centuries. They don't call it a product. They don't sell it. They collect it from the forest floor near their farms, ferment it for a week, dilute it in water, and pour it onto their beds. The liquid costs $0 to make. The inputs are rice bran, brown sugar, water, and whatever is already living under the old leaves in the nearest stand of trees. That's it. The results are not marginal. Plants treated with this liquid recover from stress faster, resist disease more effectively, produce denser root systems, and yield more than untreated controls. Not by a small margin. Consistently, measurably, visibly more. Commercial biostimulant products attempt to replicate this. A bottle of mycorrhizal inoculant runs $28 to $45 for enough to treat a few transplants. Liquid bacterial concentrates cost $35 to $80 per quart. Kelp extracts, humic acid solutions, compost teas sold in concentrate form. The market for these products is large and growing because growers know the soil biology argument is real. They're paying for something that Japanese farmers have been making in a bucket for nothing. The principle is the same. The execution is cheaper by a factor of several hundred, and the locally collected version works better because the microorganisms in it are already adapted to your specific climate, your specific soil conditions, your specific pathogens. Here's what the liquid actually is. In the forest floor under old-growth trees and stands of bamboo is the most biologically dense environment most growers have access to. The layer just beneath the surface leaf litter, the dark, slightly moist zone where the leaves have begun to break down but haven't fully decomposed, is colonized by indigenous microorganisms. Bacteria, fungi, the organisms doing the decomposition work. You can see their presence as a white, thread-like coating on the underside of half-rotted leaves and on pieces of bark. That coating is mycelium, living fungal network. This is what you are collecting. This is what goes into the liquid. This isn't mystical. It's microbiology, and it's been working for centuries. The collection process is simple. You find a shaded area with old leaf litter. Under a stand of trees, the base of a hedgerow, the edge of a forest. You look for the white mycelium threads on the underside of leaves. You gather a double handful of this material, the partially decomposed leaves with visible fungal growth, into a wooden box or a cloth bag. Do not use plastic bags for collection. They trap moisture and begin anaerobic decomposition before you get home. You want the living material intact. Cost, $0. Time, 20 minutes. Once you have your collected material, you begin the fermentation. This is where rice bran enters the system. Traditional Japanese and Korean farmers use rice bran because it is the byproduct of rice milling, cheap and widely available. You can use wheat bran, oat bran, or spent grain from a home brewery. The bran provides the carbon food source that allows the microorganisms to multiply rapidly. You mix 1 part collected forest material with 1 part bran by volume. You add brown sugar at roughly 5% of the total weight. The sugar accelerates the fermentation and feeds the bacteria specifically. You mix it together until evenly combined. The consistency should be damp but not wet. When you squeeze a handful, it should hold its shape but not drip. You pack it into a container. A ceramic crock or a food-grade bucket works well, and you cover it with cloth tied at the rim. Not an airtight lid. The fermentation is aerobic in its early stages. You need airflow. You leave it at room temperature, ideally between 65 and 80 degrees Fahrenheit, for 7 to 10 days. Check it on day 3. It should smell slightly sweet, slightly earthy, slightly sour. That smell is beneficial bacteria multiplying. The temperature inside the container may rise a few degrees above ambient. That is normal. That is the biological activity you want. By day 7, the material smells fully sour and fermented. The color has darkened. If you see any black or green mold on the surface, scrape that layer off and discard it. The material below is still usable. Black and green molds indicate contamination from environmental spores, not failure of the fermentation. The white and gray material underneath is what you want. Cost, under $2 for bran and sugar combined. Time, 10 minutes of active work, then 7 to 10 days of waiting. What you have at the end of this process is a concentrated colony of indigenous microorganisms adapted to your local environment. Bacteria that fix nitrogen, fungi that form mycorrhizal relationships with plant roots, organisms that suppress pathogenic fungi by outcompeting them for space and resources in the root zone. You've collected them from the most biologically rich environment near your farm. You've amplified their population using bran as a food source. You've created the workforce your soil is missing. And you've done it for almost nothing. The forest made them. You borrowed them. Now you put them back into the ground where your plants need them most. To use the fermented material, you need to extract the liquid. You take the finished fermented matter and mix it with water at a ratio of 1 part fermented material to 10 parts water. Stir it thoroughly. Let it sit for 30 minutes. Then strain out the solid material through a cloth or a fine mesh strainer. What remains in the water is brown, slightly cloudy, and smells earthy with a faint sour note. This is your inoculant solution. This is the concentrate. You dilute it further before applying it to plants. For a soil drench, dilute the concentrate at 1 part to 500 parts water. 1 cup of concentrate into roughly 30 gallons. For a foliar spray applied directly to leaves, dilute at 1 to 1,000. The higher dilution for foliar application matters. Concentrated solution on leaves in direct sun can cause burning. Apply foliar sprays in early morning or late evening when temperatures are below 75 degrees and the sun is not direct. Never apply to plants under extreme heat stress. The leaves need to be able to absorb the liquid without losing moisture faster than the application adds it. For soil drenching, timing is more flexible. Apply in the morning. Use enough volume to thoroughly wet the root zone, not just the surface. For a standard raised bed, 2 to 3 gallons of diluted solution per application is enough to reach 12 inches deep. You want the microorganisms delivered to the root zone directly, not sitting on the soil surface waiting to dry out before they can establish. Cost: nearly zero per application. Time: 5 minutes to mix and apply. Apply every 2 weeks during the active growing season. Once per month is sufficient as a maintenance dose after the first 2 months. You are not trying to flood the soil with microorganisms. You are seeding a population and giving it time to establish. After the first 2 or 3 applications, the native microbial community will begin to self-sustain if you stop disturbing the soil with tilling and reduce or eliminate synthetic inputs that disrupt soil pH. The microbes do the rest. To keep a continuous culture going, reserve 1/4 of your fermented material before you strain it. Add fresh bran and a small amount of brown sugar. Add a little water to bring the moisture back to the right consistency. Cover it again. Let it re-ferment for another 5 to 7 days. You now have a new batch ready without another collection trip. The culture compounds. One collection from the forest floor can sustain a continuous fermentation operation for an entire growing season. Cost: pennies per batch. Time: 5 minutes to refresh. Here is what happens when you start using this system. Week 1. You apply your first soil drench to the raised bed where your plants have been struggling. The plants look the same for the first 2 days. This is normal. You are not adding nutrients. You are seeding biology. By day 3 or 4, you may notice the leaves look slightly more upright, less limp in the afternoon heat. The stomata are recovering. The roots are beginning to encounter living organisms in the soil for the first time and responding to the chemical signals they release. Week 2. New root hair growth is developing. You won't see it without digging, but you can observe the above-ground effect. Plants that were static are putting out new leaf growth. Transplants that were sulking since you put them in the ground are starting to push. The soil itself smells different when you water. Earthier, richer, less like wet potting mix. More like the forest floor where you collected the material. That smell is biological activity. That's what healthy soil smells like. Month 1. The plant that was failing when you started is now showing 4 new leaves. Full size, not stunted. You haven't applied any fertilizer. You haven't added calcium or adjusted the pH. The only thing you changed was the biological life in the root zone. The roots are doing what roots are designed to do when the soil community is intact. They are exchanging carbon for phosphorus through fungal networks. They are accessing nitrogen fixed by bacteria at the root surface. They are physically defended against pathogenic fungi by beneficial organisms that outcompete them. The plant is not dependent on your next purchase. It is connected to a system. Month 2. You apply your third drench. Leaf color has deepened. Not the pale, slightly yellow-green of a plant on synthetic nitrogen, but a rich, dark green that comes from actual chlorophyll density. Your neighbor asks what you're doing differently. You tell them. They don't believe it costs nothing. You show them the bucket. Month 3. You are buying no inputs. Feed bill for this bed: $0. The plants are producing. Dense root systems you can see when you harvest and turn the soil. Fruit with color and weight and flavor that comes from a plant that was never stressed into producing early, never propped up by chemicals, never fighting off a pathogen burden it couldn't handle on its own. This is what the raised bed in the hook looked like at $300 of sunk cost and half-dead plants. It wasn't a bad bed. It wasn't bad seeds. It wasn't bad technique. It was empty soil. Then biologically empty. Sterile medium with plants trying to grow in it the way a person tries to function without sleep. Eventually, everything fails. You were not the problem. The design was the problem. Microbes are not an amendment. They are your workforce. You don't spray for fungal disease because the beneficial fungi in the root zone suppress pathogens before they establish. You don't buy nitrogen because the bacteria fix it at the root surface. You don't buy root stimulators because the mycorrhizal network is already doing the job those products attempt to replicate. You don't manage plant stress with products because plants connected to a living soil system are not chronically stressed. They are supported. Start with the collection. Find the nearest stand of old trees. Look for the white mycelium on the underside of half-rotted leaves. Gather a double handful. Cost, 0. Time, 20 minutes. Ferment it with bran and brown sugar for 7 to 10 days. Cost, under $2. Time, 10 minutes of active work. Dilute and apply to your beds every 2 weeks. Cost, nearly 0. Time, 5 minutes. That is the system. 3 steps. No products, no subscriptions, no dependency on a garden center. Japanese and Korean farmers figured this out by watching what the forest does and asking how to bring it to the field. The forest wastes nothing. Leaves fall. Microbes consume them. Nutrients return to the soil. Plants grow. Everything cycles. Your garden can work the same way. The biology is already living near you. You just need to collect it, amplify it, and return it to the ground where your plants are waiting for it. Nothing wasted. Everything cycles. The forest figured this out. You are just learning to read it.